So, good morning everyone, my name's Harv Saund. I'm Technical Specialist here at Autodesk for Fusion 360, and today we're going to go ahead and take you through an introduction to Fusion 360. So we're going to go ahead and show you a whole host of different information regarding Fusion 360 itself. So we'll initially talk about what we term here at Autodesk the future of making things, and what we'll then go ahead and move into is a full technical demonstration of Fusion itself, showing the power of the platform itself. So first things first, this future of making things here at Autodesk. Now we went to go ahead and talk to a load of our customers about how they design and how they work. And what we found is they have a very traditional product lifecycle when creating components. They start off within a concept phase. Now, pardon the expression, but this could be a fag packet sketch, or it could be very quick concept sketches or rudimentary 3D models. They then move that into more of a production level design phase. So this is where they start to create all the 2D content or 2D drawings, PDFs, bits and pieces such as that. Then they move into a production phase, so again using traditional techniques such as subtractive and additive or subtractive manufacture, and actually assemble the product at that stage, move into selling the product, and then go ahead and have to operate and retire that product. So it will have a specific life cycle to it. And this is what we term a traditional product lifecycle because it's very linear in its approach, and when we get to the sales, operation, and retire phase, we're having to think about the next generation of product or the next kind of product we're going to be releasing to market. So this has what we term a fixed product value because we're having to repeat that process over and over again. Now what we're looking at doing is changing that slightly. So during the concept phase, we have a bit more personalization from the customer, having the ability to have them engaged a little bit sooner in the process. During the design phase, we can go ahead and start to look at collaborating with multiple teams, whether they're on our site or not, or even in a different geographic location. During the production phase, we take into account the technological advancements in manufacturing, such as additive as well as subtractive manufacture. So having the ability to maybe metal 3D print something and then do some final machining toolpaths to it. During the sales phase, the customer's already a little bit more engaged because the product's a little bit more customized to them. And also during the operation retire phase, the product's out in use, and what we can go ahead and do is look at connecting that product to IoT and Industry 4 and gathering some of the data as how that product's being used so that we can then go ahead and inform the next level of design or the next generation of product that we release. Now we term this product as a service because we're not just selling the product, but we're also selling all that services and the connected services with that, which goes ahead and gives us the ability to have what we term a more increased lifetime value and an agile product development process, because while that product's being used in field, we can then go ahead and start to plug all of that data back into our design process and follow this all the way through again. And this is what we term the future of making things. Now to solve this, we have something called the Product Innovation Platform. At the center of this, we can go ahead and do all of our design work. So this will be our concept level design, so our very quick rudimentary 3D models, having the ability to then move those into more of a production level design, bill of materials, 2D drawings, having the ability to communicate potentially how that design is going to work, fit, form, and function. We can then go ahead and look at doing stress testing at that stage as well. Moving that into the make space, so having the ability to do subtractive manufacture, so your standard CNC manufacturing, so you can quickly and easily start to go ahead and generate that product. Kind of what I like to term as art to part. And then also with the use phase, we mentioned about connected products and having the ability to connect that design to IoT and industry, so we can then go ahead and see how that product's being used. This gives us a complete solution as we can then go ahead and start to inform that design process a little bit sooner. And we're expanding on that. So with Fusion, we're having the ability to quickly and easily start to expand on that toolset, giving us the kind of toolsets that we need to make sure that we've got all of that design data in place. Breaking down that wall between design and make and having the ability to quickly and easily start to rapid prototype something and then move that into a production level design, reducing the amount of prototypes to do that and having the tool sets built within the platform to quickly and easily manufacture. And then moving that into use, not just looking at just the product being used in field, but also potentially looking at factory utilization, having the ability to go ahead and see what products or what parts of your factory are actually going ahead and working efficiently and what aren't. So this gives us an integrated product development platform, a single platform to take design from concept all the way through to production, starting off with form or concept design, having the ability to quickly and easily create some very quick rudimentary models, move that into function, having the more production level design, the 2D drawings, the 3D models, all of those bits and pieces into the fabricate to then go ahead and put machine toolpaths to those, and then managing all that data in an overall layer and having the ability to look at previous versions of that design. Now you can find Autodesk Fusion 360 on a whole host of different social media channels. You have we have 3 down at the bottom: the Twitter handle, the Facebook, as well as the LinkedIn. So if you did want more information, you can find us on social media just there. Now, the reason we built Fusion 360, we went to all of our engineers, all the customers that we deal with on a day-to-day basis, and asked them what they wanted from the next level of CAD that they want to go ahead and use. And one of the key things that came from that is that they wanted access anywhere. So having device independency was key to them. So instead of being tied down to a specific hardware vendor or a specific hardware specification, they wanted the ability to use a whole range of different hardware and actually have the ability to access their data anywhere and at any time. One of the key things for Fusion is we're not specific to hardware. So we can run on a Windows machine or we can run on a Mac if we needed to. We can also access the data that we're creating anywhere and at any time. So all of that data is in the cloud, so we can quickly and easily start to go ahead and access that, whether that's at midnight here in the UK or whether that's in China or Japan or wherever. So it gives us the ability to quickly and easily almost be instant on. They also wanted to go ahead and be completely connected with the teams that they're working with. Now these teams could be manufacturing sites outside of their geographic location or even different sites within the same country. And what Fusion 360 allows them to do is have the ability to be constantly connected with those teams, which we'll be seeing in the actual webinar itself. Having the ability to communicate, mark up, and actually collaborate instantly within their manufacturing cell or the product itself. So that was one of the two of the key reasons why we built Fusion 360. It's completely integrated, so we have a completely integrated platform which we'll be showing you, so taking design through to manufacture, having the ability to be connected, having the ability to get feedback from different stakeholders and different people in the business to how that product's going to develop, and having the ability to be accessible. Again, not tied down to a specific hardware, and also not having to take memory sticks or flash drives or portable hard drives anywhere. So having the ability to constantly be able to access that data as need be. So let's jump into the actual technical demonstration of Fusion. So we're going to take about 50 or so minutes to go through this, and I'll take breaks as we go through it. And like I mentioned, if there are any questions, you can drop them in the poll or in the questions tab, or go ahead and drop us an email afterwards. So we're going to go ahead and concentrate on this design, make, and use, and we're going to concentrate on the design and make portion within the actual webinar itself. And first things first, for design, we're going to go ahead and take a look at concept as well as production level design, and then also go ahead and take a look at some of the other tools within Fusion that can help you during that product development process. Having the ability in the top right hand corner to go ahead and work with what we term freeform or T-splines, so having the ability to pull in a canvas and then start to push and pull and create the data or really freeform ergonomic shapes, and then moving that into a more production level design where we go ahead and create parametric features such as ribs, cuts within that design, having the ability to quickly and easily start to toggle which features you want, and then also going ahead and looking at some communication, so actually communicating that design with whoever we need within the design process itself. So let's jump into Fusion. Let's go ahead and take a look. So we're going to go ahead and initially concentrate ourselves on the T-spline element. We're going to go ahead and look at how we can import a canvas into Fusion. So this could be just a very rough sketch that someone's put together, bring that into Fusion, use it as a reference, and then start to push, pull, and start to create that freeform body of this reciprocating saw. And then quickly and easy start to adjust that, add certain elements to that design, and then start to build that body quite quickly within Fusion itself. So let's jump into Fusion. Let's go ahead and take a look. So Fusion 360's interface is very clean, very simple. So you have the toolbar along the top so we can access all of our tools. We also have the data panel on the left-hand side of the screen, which houses all of our data within different projects itself. So a whole host of different projects, and under each project you can then have subfolders, and then you can start to look at having all of the data within each of those subfolders itself. So let's go ahead and take a look at how we generate that freeform body for this design itself. So the first thing that I want to go ahead and do is maybe import a canvas into Fusion. Now this canvas is going to be a very rough sketch that we've gone ahead and used. So really quickly and easy we can go ahead and specify that image that we want to go ahead and work with. So I'm going to go ahead and pick that from a file location on my desktop or on my laptop itself, and these can be PNGs, JPEGs, TIFF images, and we can then go ahead and start to look at scaling that to be the right size. So I'm going to go ahead and just drop the opacity a little bit so I don't see that as a prominent image directly within Fusion itself, and we're kind of about the right size, but what I want to go ahead and do is give this a specific size. So quite quickly within Fusion we can go ahead and start to look at calibrating the size, giving this an overall dimension, and then adjusting its position to make sure that it's sitting exactly where we need it to be within our design environment. So from here, let's go ahead and start working on creating that freeform body that we see that's generated from this sketch itself. Now the first thing I want to go ahead and do is jump into our freeform environment. So from our sculpt tools we can go ahead and use primitive shapes. So this is kind of like using Play-Doh or plasticine. You take a primitive shape and then you start to push and pull. Or we can just go ahead and use flat surfaces or 2D faces itself. So for this design I'm going to quickly use a 2D face. I'm going to just snap to the front view and we're just going to initially position it where these vents are. So it makes it very quick and easy for us to just generate what we term a subdivisional face just there. So using that subdivisional face, we're going to go ahead and use a tool called Edit Form. What this is going to allow us to do is then start to look at pushing and pulling that shape to get it to about the size and shape and position that we need it to be. Now this body obviously needs to encompass the motor and bits and pieces, so I've pulled it out a little bit further than it needs to be. So now that we've got that position of where this body is going to start, we can get rid of all of the internal components because I'm not interested in those. So let's go ahead and start to develop this design. I'm going to jump back into that Edit Form tool, and just holding down Alt on my keyboard I can quickly start to generate extra divisions off of this face, which gives us the ability to quickly and easily start to create the areas that we need to then start to push and pull. I can go ahead and box select specific areas, we can scale, we can move, and if I wanted to go ahead and rotate maybe that edge, we can. So really quickly and easy, this provides us a very fluid, free-form way of creating that kind of shape that we need for that design. Now I want to create a second section at the bottom, so again I can go ahead and pull that area down, and I can go ahead and move this section to start to create that handle loop at the bottom itself. So really quickly and easy we get the ability to generate already a shape that would in traditional CAD be quite difficult to do because we'd have to create sketches and planes to do that. Now let's go ahead and generate this handle section. Now this is generally going to be a rounded sort of shape, so what we'll use is again another primitive, and again we can quickly and easily start to generate that shape. I'm going to make it about 40 millimeters. We can increase its size and we can also increase these divisions as well. Each of these divisions we can then go ahead and individually push and pull as we need to. So once that's in place, what we can go ahead and do is if I just double click on that body, we can then go ahead and move that to the position that we need it to be in. And what we'll do is we'll scale this in a moment. So quite quickly we can then go ahead and make that kind of size that we need that to be. Now we're only working on half model and we'll mirror a little bit later, so what I can go ahead and do is get rid of these sections of that subdivisional model, and then we can start to manipulate and push and pull this area as well. Now what I want to go ahead and do is just pick up on a couple of these edges. So we have a couple of edges just here and here that I want to go ahead and add some data to. So again, just using that same environment, so that Alt that I used earlier, I can quickly and easily start to push and pull and get those to kind of the shape that we need them to be. Again, scaling or moving exactly where they need to be. Now what I want to go ahead and do is just bridge these to here and here. So this would then create the bottom section of that handle. But we need to go ahead and add in an edge just here. So really quickly and easily within Fusion, we can do that by just hitting our Insert Edge tool, and it gives us that ability to do that. So let's go ahead and bridge these together. So all I'm going to go ahead and do is just pick up on the side itself. So we'll go ahead and pick up on a couple of edges just here, and we're going to go ahead and bridge that to those edges just there. We have the ability to go ahead and look at a preview and also choose how many divisions we want in that area. And very quickly and easily we then go ahead and get that complete division that we need, and bridging that together exactly as it should be. Again, using traditional CAD methods, we'd have to look at creating potentially lofts to do that on different sketches and different sketch planes. Now I'm going to add in another section just down at the bottom because we want to go ahead and just level out the design itself. So again, just using some box selection. And again, very quickly, just by eye trying to line this up with the actual design itself, we can add points and edges where we need them to be. So it makes it very fluid and very flexible when going ahead and creating some very freeform ergonomic shapes directly within Fusion. Now I just want to bring this section up a little. So again, we can go ahead and maybe bring that handle point just down. So very quickly, we're actually going ahead and adjusting this design to what that customer needs or what the customer's suits are. So I may want to go ahead and bring that section a little bit further out, maybe adjust this one and push that and pull that back in. Now that's great. We've created the bottom section quite quickly within Fusion, but we also need the top section. So again, what we'll go ahead and do is I'll just move that down a little. And again, just holding Alt on my keyboard, we'll go ahead and create some segments just here. And again, all I'm doing is very quickly pushing and pulling to then create another further segment within the design itself. We'll make that about straight just there. We'll neck that in slightly, and again we'll go ahead and just fit this to the design and where that design actually needs to go ahead and be. Again, very quickly, as you can see, I'm picking up on points but or vertices. We can also go ahead and pick up on edges or even faces to go ahead and do this. Now we're at this point here. We also need to go ahead and add in another segment just here, and maybe what we also want to go ahead and do is just pick up on these two edges and add in another segment to those. So I'll just rotate around slightly, and again what we'll go ahead and do is we'll just add in a segment just to finish off that handle. But we'll also go ahead and add in another segment just here, and we also need to go ahead and break this face just here into two. So again, using that same technique that I used earlier, we'll insert an edge, and we'll use that same tool that I used earlier with bridge to quickly and easily go ahead and manipulate this shape. Very quickly we then go ahead and get that bridge in place, and again it's looking a little bit tight just there, so using our freeform tools or our edit form tool, we can quickly and easily start to adjust that shape to exactly what it needs to be. Again, giving us the ability to quickly and easily get that real freeform, very fluid looking shape directly within Fusion. Now we're kind of there. What we need to go ahead and do is just finish this design off. So what I'm going to do is just pick up on a few of these edges. So I'm just going to hold down Shift on my keyboard so we can pick up a few of these. There we go. I actually want to pick up less of those, so let's just pick up on those just there. And what we'll also go ahead and do is just create 3 segments from these, 1, 2, and 3. There we go. Now that's great, but nothing joins together. So what we'll do is, again, using some of the really intuitive tools within Fusion, we'll have the ability to quickly and easily start to weld all of these vertices together. So it makes it very quick and easy for us to go ahead and create the kind of shape that we need from Fusion itself. So really quickly and easily what we then create is a very complex shape very simply within the Fusion environment, giving us the ability to quickly and easily create multiple concepts at that stage if required. Now we've only been working on half of this model, so let's hide away that canvas and let's create the other half. Now I'm just going to go ahead and flatten these faces off just here. So what I want to go ahead and do is just make sure that these are completely flat to a plane, and then we can then go ahead and start to look at adding symmetry within that design. So we'll just duplicate this design, we'll create that mirror plane, and symmetry is automatically added when we do that. So whenever we make a change on one side, it will then go ahead and propagate to the other. So again, making it very flexible, very fluid when going ahead and creating components within Fusion. Now I may want to go ahead and create a variation of these. So what we can go ahead and do is just quickly use the standard tools that you guys are used to, copy and paste, to quickly create maybe 2, if not 3 variations of this design, giving you the ability to quickly and easy start to look at how we can develop that next generation of product. So again, giving us the ability to individually make changes to each of these designs without actually having to change the original itself. So again, very quickly we can go ahead and start to give people an option, have the ability to give them a say, and we can do that by using the CAD collaboration tools within Fusion. So we're not having to go ahead and take a screenshot of this. We're not having to go ahead and maybe take individual images or individual renders directly within Fusion. We can go ahead and start to look at commenting. So we can go ahead and say 3 concepts done. What do you think? Which is the best? So really quickly and easily using that commenting tool within Fusion, we can upload a post for this design, and we can then go ahead and start to gauge from people what they're thinking is the best design going forward. So once this is uploaded, we can then go ahead and jump into the communication environment, and from that we can then start to develop this design a little bit further. So we can open those designs directly on the web browser. So we'll go into this in a little bit more detail a little bit later, but we can quickly and easily have a web browser view of that design. So it gives us the ability, instead of installing something from a package, we can go ahead and start to look at who's using that design initially. You can see that I'm using it at the moment. And we can then start to delve in and start to see all the comments that are created version specific. So again, we have the ability to just send a link to someone and share that design with someone, and they can then go ahead and start to view it. They can zoom, pan, rotate. This is a design that we've just created, and they can then go ahead and start to look at commenting on parts or objects within the design. This one looks the best. Can we move forward? And if we post that, that will then post that comment, gives that a little bit of a refresh, and then when we pop back into Fusion and give Fusion a little bit of a refresh, that comment exists instantly. So it gives us the ability to have instant in-CAD collaboration, having the ability to quickly and easily start to iterate that design and communicate with whoever we need to. So again, using those tools within Fusion, we can quickly and easily start to generate that design, so have the ability to have freeform modeling within Fusion itself, having the ability to quickly and easily create bridges and actually create that real freeform curvature continuous shape directly within Fusion itself. Now moving this design on a little bit, what we want to go ahead and do is start to look at the parametrics within the design, actually creating some features, maybe some vents for that motor. So again, we're having the ability to go ahead and use standard sketching tools that you guys are used to, having the ability to use patterns, again, very standard tools that you guys are very used to, and then start to look at jointing everything together and making some moving mechanisms. So again, let's jump back into Fusion. Let's go ahead and take a look. So we're done with that handle or the housing itself, and we can see it just here. So let's just go ahead and start to look at how we add extra data or extra detail into our design. So I'm going to just go ahead and start a sketch quickly, and then from that sketch we can then start to use the standard tools that we're used to. So I use my right-click menu a lot, but you can also go ahead and access these tools from the drop-down. So I can go ahead and pick on my line tool, and we can quickly and easily start to generate the kind of tool that we need within Fusion. So very quickly we can then go ahead and generate maybe a event for the design. We can also go ahead and start to look at putting in dimensions. So if I wanted that to be, let's say, 15 millimeters, we have that standard parametric environment that you can go ahead and use. Just going to add in another line just here, which is going to dictate our pattern. And then from there, we can use our standard tools such as patterns to go ahead and quickly and easily start to generate this shape itself. We can specify directions and also instance counts. So I only want 2 of those. So quite quickly, we can then generate all the bits and pieces that we need for that design. So if I make that about 25 millimeters, I can repeat that pattern, specify the elements that I want and the direction, and very quickly we have the ability to have everything that we need within that design itself. So I want 10 of these instances instead of just 1. So we'll go for 10. And again, if we just go ahead and pick that direction, he says, let's try that again. There we go. We'll go ahead and pick that as my direction. It's going off in the wrong tangent, but we'll go for that again. I'll just restart the tool quickly. There we go. We'll go for 10 of those. There we go. So again, very quickly, we can then start to generate the kind of vents that we need. Now, I only want 3 at the top, 3 at the bottom. So again, we can pick the instances that we want. Now, I've created a sketch. I now want to go ahead and create an extrude. Now, in previous or in other CAD solutions, what we'd have to go ahead and do is jump into a different command to do this. Now, I'm still sketching. I can hit the S key on my keyboard, and from here, I get my sketch toolbox appear. So from here, I could actually go ahead and just pick up extrude. And I can do a search and go from 2D to 3D quite quickly. And from that, if I just show the previous body, what we can then go ahead and do is start to create a cut, either on a single side or completely symmetric, that will then go ahead and create us those vents, giving us the ability to quickly and easily start to iterate that design and create those elements itself. Now, we may also want to go ahead and create a few ribs in the design itself for strength. So again, we can go ahead and pick up on, let's say, a web plane just here, which is a construction plane. And we can also add in that data as well. So again, if I just go ahead and pick up on my line tool, I can quickly start to add in all the ribs required for this design. So again, quickly and easy, we'll add in 3 of those ribs. And again, using that search function within my sketch toolbox, I can jump from a 2D directly into a 3D environment. So from here, I can quickly add in all the elements that I need. So those 3 just there. I can go ahead and give that maybe a size of 2 millimeters, and very quickly that rib is added. Now, we also want to go ahead and create a cut so that we've got enough room for all the mechanisms to fit. Again, I can go ahead and just specify a rectangle to do that. And I'm just going to go ahead and specify it a specific distance. So we can go ahead and give this a size, maybe let's say 10 mil deep, and maybe 25 mil tall, and I can also go ahead and specify where that's going to be from a specific edge itself. But taking that design, I can use something called press pull. Now, press pull goes ahead and gives us the ability to use or automatically decide what kind of tool we're going to be using. Now, because that's a sketch and I'm cutting through components, it's automatically going to go ahead and default to the extrude. But if I wanted to go ahead and offset a surface, the press pull tool is clever enough to go ahead and understand that. Now I'm going to go ahead and do this to an object, so we'll go to that side just there, and what we can quickly and easily see is we've got an issue. So we've actually cut through this boss. Now, that's not great. In traditional CAD, what we'd have to go ahead and do is pop back into the sketch. We'd have to then go ahead or pop back into the dimensions, make a change to the dimensions, specify another dimension to go ahead and change that. But what we can go ahead and do in Fusion is if I want to go ahead and just get rid of the notch in that boss or that mountain boss, I select that face, hit delete on my keyboard, and it automatically repairs that for us. So a very powerful set of tools directly at your disposal directly within Fusion. Now, once those ribs are done, what we want to go ahead and do is maybe create an overmolding for this design on this outside face. So we need to split those faces up. So I'm just going to go ahead and show a sketch that I'm using to do that. So this is our overmolding sketch. And what we'll go ahead and do is we'll quickly use our split face command to do this. So again, just specifying the faces that we want to go ahead and split. We can quickly select that sketch and we have that almost overmolding that we can go ahead and use. Now again, I want to go ahead and offset these surfaces by maybe 1 millimeter. Again, in traditional CAD, we'd have to use surfacing to do that, not in Fusion. Using our press pull tool, we can quickly and easily go ahead and offset those faces by 1 millimeter very easily directly within Fusion. And it automatically defaults to that offset faces command, and it gives us the ability to use that 1 mil offset. So again, giving us a very quick and easy way of offsetting that design. If it does go too far, it does go ahead and show us some errors that we can go ahead and work with. So I'm going to just go ahead and use 1 mil. What I need to go ahead and do is select all the faces as well. So let's just pick up on each of these faces that I want to go ahead and use. So I'll just control select each of these. And we'll go ahead and give that a specific size. I've gone a little bit too far just here. That's okay. Once it's picked everything, it will flick back for us. There we go. And there we go. So that was user error more than anything. It was my fault just there. So if I click OK, it gives us a 1 mil overmolding very quickly within Fusion itself. So again, specifying those faces, we can quickly and easily add that to that design. Now again, using that same command, or using the same technique, so selecting those faces, what we can go ahead and start to look at is start to apply appearances to this. So from here we can go ahead and have a whole host of different appearances. Now these are the appearances that are already added to that design, so I can actually just go ahead and right click. We can add any of those to our favorites, we can edit, we can duplicate those, or we can go ahead and drag and drop those to the direct face that we need them to be on. So it gives us the ability to quickly and easily start to create some very high detailed renders or high detailed images directly within Fusion itself. So let's just jump back to the PowerPoint quickly. We've gone ahead and looked at some of the parametric capabilities. So from there we can quickly and easily start to create sketches. We can go ahead and create cutouts and ribs and webs that we need for that design. We can then start to develop that design a little bit further. Now what we want to go ahead and look at is moving mechanisms. How do we go ahead and put everything together and start to create some mechanisms or moving joints within the design itself? So let's jump back into Fusion. Let's go ahead and take a look. So one of the key things that we want to go ahead and do is we've got an assembly just here. So let's go ahead and bring back those components that we hid earlier on. So I'll select those selection sets that we hid earlier on, and let's bring those back in. Now these gear components at the top, they're all free at the moment, but one of the key things for us within Fusion, they've all been built within this environment itself. So what we can go ahead and do is start to quickly add in all those moving mechanisms that we need. And we use a tool called joints to do this. So I'm going to quickly activate what we term an as-built joint. Now what this allows us to do is specify how two components react together or join together. Now at the moment I'm saying that these two components are completely rigid, so in effect they're fixed. But what I actually want them to be is revolving, so that gear to revolve around that shaft. So all we'll go ahead and do is release that degree of freedom that we need. Specifying where the axis is going to go, very quickly we can then start to look at how that design reacts. So it gives us the ability to see that that design is going to revolute around that axis. Now just repeating this command, we can quickly and easily start to build up that mechanism within Fusion itself. So I'm going to specify these two components and then that axis just there, and again what we can go ahead and do is just repeat that command. We'll do it here to here, and again giving us the ability to quickly and easily see the animation within that design itself. So I'm going to pick these two components just here. So let's pick that gear housing as well as that slider component, and this actually needs to be a slider. So what I want to go ahead and do here is just specify that edge to then slide across that design. And what I also want to go ahead and do is make sure that this circlip moves with everything as well. So we'll go create what we term a rigid group. So I'm going to specify those two components just there. That's going to go ahead and make those rigid. Now as I move that design or that gear, as you can see, everything rotates and moves as it goes. Now to do that in traditional CAD, what we'd have to go ahead and do is put in a whole host of different mates and constraints to make that work. I mean, just for this gear, we potentially have to put in a width. We'd potentially have to go ahead and put in a concentric around a shaft. We then have to go ahead and maybe put in a limit so that it then goes ahead and has a specific limit to move through, or just leave it concentrically free. And that's 3 or 4 joints or constraints that we'd have to put into the design. Instead of that, using our joint tool, we can quickly and easily do that within Fusion itself. And if we wanted to go ahead and maybe animate this model for someone, we can quickly and easily do that within Fusion as well with just a right click. Showing someone an animation gives them the ability to see all the detail within that design itself. And within a couple of minutes I've been able to go ahead and do that using the innovative tools directly within Fusion to do that. So again, what we've gone ahead and looked at is adding all of those parametric features. We've gone ahead and looked at how we can add in all the joints to our design, having the ability to add overmolding, and also go ahead and add appearances, and very quickly and easy start to build up that complete assembly that we need, that we can then go ahead and export and generate all of that content for. Now moving this on a little bit, what we also want to go ahead and do is test this design. So having the ability to quickly and easily make sure that that design that we're creating is suitable and fit for purpose. and doing that directly within Fusion in a virtual testing environment before actually going ahead and creating the prototype for the design. So that's exactly what we're going to go ahead and do here. So let's go jump into the simulation environment. So again, up in the top left-hand corner, we have a completely integrated platform. So we can switch from a model space where we are now, where we're designing the product, directly into either rendering, animation, CAM, or even simulation. So if I jump into simulation, Fusion gives us a whole host of different simulation tools that we can go ahead and use to test our design. Now we're working with finite element analysis here. So we can do bits and pieces such as static stresses, modal frequencies, thermals, especially if you're going to be running PCBs within the product. We can go ahead and look at buckling, nonlinear, event simulation for dynamics, as well as the first level of generative design called shape optimization, which looks at topology and how we can optimize the shape of our product. Now for this design, we're only going to go ahead and look at static stresses. Now FEA can be quite daunting, especially if you haven't used it for the before in an environment, so you do have the option for a study advisor to help you choose the type of study that you want to use. So if we click OK at that stage, we're into the simulation environment. Now at this stage, all I want to go ahead and simulate is a 330 Newton load on this part just here, and how that reacts with this component and this component just here. So I don't need everything else. So what I can go ahead and do directly here is just double click on each of these parts itself. And I've got those selected. All I need to go ahead and do is right click and suppress everything else away. So I'm not having to go through trees or go through in the modeling environment and suppress everything off. We can do that directly within the simulation environment. Now that we've got everything together, what we can go ahead and do is start to set this simulation up. Now Fusion works in a very logical, very simple way. We start from left and we work our way right. So initially we can set up some materials. So if it's going to be steel or ABS, we can go ahead and work with those. You can specify those at an individual model space or even for the whole assembly itself. We can then go ahead and start to look at putting in constraints. So these are just fixtures. So these are where is that part going to be bolted in a real life scenario. And for us, for this gear housing, it's going to be bolted on those two faces just there. We want to go ahead and apply a load to the design, so we can specify where that's going to be, and also the magnitude of that load as well. So we're going to work with 330 newtons, and that can be directed in a specific angle or a specific edge itself. Now once that's done, what we can go ahead and do is, prior to running the simulation, is just pre-check it. Make sure that we've got everything in place that we need before running the simulation. And we can do that in two ways. We can look at a degree of freedom check, so make sure that everything is bolted or bonded together as it should be, or go ahead and run a pre-check. So this is going ahead and checking the model to make sure that everything works as it should do, or it's got enough detail in that simulation before running it. So it's saying to us that we may need to go ahead and look at adding contacts. Now what contacts are is just how each of these components will interact with each other. So we can add in different types of contacts so it makes it work as it should do. So I've just added those contacts in, and we look at the degree of freedom check again, and it says it's fully fixed. So again, it's making sure that everything is solving as it should do. And then from here, what we can go ahead and do is hit the solve option. Now with Fusion 360, we give you the option. So we can actually go ahead and chuck all the processing required to solve this simulation up to cloud. So it gives us the ability to quickly and easily choose the hardware that we want. We're not tied to having a very beefy machine in the corner that's going ahead and churning out simulations. Or if you do have the hardware on your machine, you can run this simulation locally, like I'm going to go ahead and do now. So if I hit solve, this is then going to go ahead and start to take all of that data that I've created, or that information that I've created for this simulation, and start to run it. So it's going to go ahead and break this design down into small elements, what we term finite element analysis and what we term meshing within that. And we have complete control over that mesh, so if you did want to make some changes, you can. And this is then going to go ahead and run that simulation. It will take a minute or two just to run, and then once it's done, we can go ahead and start to look at the results that we get within Fusion itself, and start to interpret those results and see how we can improve that design a little bit better. So as we can see, we get those results back, and we can instantly see from Fusion, it gives us a quick results detail. So from here we can actually see the minimum safety factor within the design is about 0.6. So that's actually going to yield and break with that 330 Newton load. And we can start to look at the weakest areas of the design, and it highlights that for us. If we wanted to go ahead and start to look at different elements of that simulation, so such as stress, we can go ahead and start to look at the stress concentrations and where they exist. So that's about 323 newtons in that area alone. Megapascals in that area alone. We can start to look at displacement, and we can also animate that plot, so we can start to see how that part's moving with that loading condition. So really quickly and easy, we can start to communicate that with someone and say, look, actually the part's going to be failing, so we need to make some changes. Now, that's great. One of the key things with Fusion is we can jump back into the modeling environment and make these changes very simply. So if we grab that gear housing and open that up on its own, we want to go ahead and make some small changes to make this a little bit beefier and actually handle that load. Now this part itself is actually imported from a different CAD solution. So this has been brought into Fusion, and from here we will actually want to go ahead and manufacture this now ourselves. So we want to go ahead and start making some changes. So one of the first changes that we want to go ahead and make is grab this face and drag it over. Now, as this is an imported a bit of geometry, generally in traditional CAD that'd be quite difficult to do. We'd have to potentially look at remodeling or adding a bit, taking away a bit. What we can do within Fusion is use what we term move copy. This will allow us to quickly and easily pick up on specific faces in that design and just grab and drag. This allows us to quickly and easily start to develop that design to being exactly what it needs to be, and giving us that real fluidity within the design process. So if I want that to be, let's say, 8 mil or even more, we can quickly and easily start to generate the kind of structure and design that we're going to be working with. So let's increase that by a further 3.5. Now, because we're going to go ahead and manufacture this in-house, we don't actually want the previous manufacturer's logo in place. So what we can go ahead and do is just highlight their logo, and again, using some very detailed tools within Fusion, delete that out. This is using what we term direct modeling. So in effect, in Fusion, what we have is the 3 paradigms of modeling: direct, freeform, as well as parametric. So it gives us the ability to give you guys the tools that you need to go ahead and start to manipulate and change those designs exactly as you need to. So I've just deleted that fillet out, so just in case we wanted to go ahead and add in our own. And if I wanted to also go ahead and delete that segment out there, we can. So again, just repatching those surfaces as we need to. Now these ribs at the back, we only need one, so what I can go ahead and do is select those faces that I want to go ahead and get rid of, or the part that I want to go ahead and get rid of. So I'm just going to control select each of these faces just here. There we go. Hit delete, and that will then get rid of that rib for us. Now it's not great because that rib needs to be in the middle. So all I need to go ahead and do within Fusion is select those faces just there. I'm just going to pop to a front view. Using that move tool, we can specify where the pivot location is going to be. So it's going to be around here, and then we can just grab and drag. So again, making it very fluid, very flexible for us to go ahead and start to look at making changes within that design itself. No need to go back into sketches, no need to go back into dimensions to do that. You can do that using the direct modeling tools directly within Fusion itself. So if I give that a quick save, what this is then going to go ahead and do is save that design for us, and then when I pop back to that my main assembly, I get a few exclamation marks appear or a few warning symbols appear. And this is just going ahead and telling us that, wait a minute, that design's changed. And what we can go ahead and then do is choose when we update that design. So again, gives us the ability to quickly and easily have the power over that assembly. So again, have the ability to choose when we want to do something rather than the software forcing us to. So once that design is completely updated, what we can then go ahead and do is just doing the final few bits and pieces is jump back to the simulation environment, and the simulation goes ahead and automatically says, wait a minute, I need to go ahead and refresh as well. So what we can go ahead and do is just rerun that simulation quite quickly, and from there we have that completely integrated process. So from here we can quickly and easily go ahead and create the model. We can go ahead and do that via T-splines or standard parametrics. We can then go ahead and add in moving mechanisms, and then when we're ready we can simulate, and we can use the direct modeling to make those changes. So it makes it very quick, very fluid to go ahead and create those changes in Fusion itself. And once that's done, we can actually go ahead and see our actual minimum safety factors increased as well. So it's about 1.57 at this stage. Let's go ahead and look at the stress within the design, and we're down to 132 megapascals instead of 330 in that same area, but we may want to go ahead and make a small change if we wanted that safety factor to be above 2. So very quickly and easily we can go ahead and start to look at developing that design a little bit further as well, using the virtual testing tools directly within Fusion. Having the ability to quickly set that study up, make those changes that we needed to for that design and rerun that analysis, giving us a quick and easy way of actually going ahead and having the correct kind of simulation, the correct design we need first time round. Again, making those changes using direct modeling and then going ahead and rerunning that design and choosing when we update. Now the final bit of the design aspect that I wanted to cover off is the rendering aspect. So again, directly within Fusion we can go ahead and render this design. So we're not having to go ahead and wait for someone else to do it, or we're waiting for a different package or moving into a different package to do this. We have very high-end rendering tools directly within Fusion. Popping into the rendering environment, we can quickly and easily start to set this design up exactly as we need it to be. So from here, if I wanted to go ahead and apply appearance to that trigger, I can quickly and easily do that directly within Fusion. We can specify what kind of appearance we want, and we can also download extra appearances directly into Fusion, and we can just drag and drop those appearances directly on screen. We can specify the scene, so if I wanted this design to be sitting in a specific environment, it can be. But we can also go ahead and start to look at focal lengths and depth of field for that design. Once we're happy with that, we can quickly run an in-canvas render to make sure that that design is looking exactly as we need it to be. And we can preview that design before going ahead and starting that render process. So it gives us a real nice finish that we can see just here, and we're using something called ray tracing. So we set a threshold and the image will just constantly refine until that threshold itself. So once we're done, we can then go ahead and choose how to render. Again, we give you the option. You can go ahead and chuck all that processing up to cloud and have the cloud render it and then send you just an email back to say, yep, that's done. You can go ahead and view your image now, or we can go ahead and do a local render. One of the key things with cloud is you can just chuck a whole host of different renders and different appearances and different changes up to cloud, and it will then go ahead and render those sequentially as well. So it gives you the ability to make a few different changes just there. Now, what we also want to go ahead and do maybe is start to look at communicating this overall design with someone. So if I just open this design up within the web environment, so let's just make a quick save just here. Let's go ahead and open the details on the web. What we can then go ahead and do again is start to communicate this a little bit more with people. So from here, I can then go ahead and start to see any products that are in use by whoever they're in use by. So again, if there are multiple people, we can go ahead and see multiple people using that product. And then from there, we can start to look at all the versions of that design. So we never get rid of any versions. They're all there ready for you to go ahead and start to look at and start to develop. And we can also compare those. And then if we wanted to go ahead and share this design with anyone, we can go ahead and just send them a link. So like I mentioned before, we don't actually have to have a whole host of different hardware or software installed. So we don't have to download a viewer, install that software, then load the design into the viewer, then do the markup. We can do it directly within a web browser. So really quickly and easily, someone can communicate on that design and just send you a quick ping back to say, look, these are the changes that need to be made. We can add passwords to that as well if we needed to. And then we can go ahead and go into our view environment and we can start to view this design. Now we're not just viewing the actual 3D model itself, but we can also go ahead and start to look at viewing the simulation results as well. So anything that you do within Fusion appears in the actual communication panel. So from here we can then start to zoom, pan, rotate. We can then start to look at different stresses, we can start to look at safety factors, and you can show someone exactly why that product would fail. Popping back into the modeling environment, what we can also go ahead and do here, let's just come out of that, let's go back into our design environment. There we go. We can actually go ahead and start to look at doing markups. So if I wanted to go ahead and point at something to someone, we can quickly and easily go ahead and draw out lines. We can go ahead and add in arrows if we needed to, and also text boxes. So really quickly and easy, we can then have that complete red line markup directly within a web browser itself, giving us the ability to quickly communicate with whoever we need to communicate with. So that's our design aspect done. Let's move this into the make quickly. So what we can go ahead and do is do a whole host of different things. Now we've done the what I consider an art side of it. We now need to go ahead and create the part side of things. So we actually need to manufacture the product. So what we have directly within Fusion is the ability to do not just subtractive manufacture, as you can see in the top right of the screen, so CNC toolpaths, but we can also go ahead and work with additive manufacture as well. So let's jump back into Fusion. Let's go ahead and take a look. So popping back into Fusion just here. Now for additive manufacture, what we can go ahead and do is just specify a component that we want to go ahead and 3D print. So I want to go ahead and 3D print that gear. From here we can either save this out as an STL and drop it into a specific 3D printing software, or we can actually go ahead and activate that 3D printing utility directly here. So I'm going to use something called Print Studio. So if I click OK, this is then going to go ahead and load up Print Studio for me, and I can then go ahead and start to set all the support structures and start to preview how that design is actually going to go ahead and be built. So I can center this to the design itself. We can add in any supports, optimize any rotation. So from here we can then start to see how that design is actually going to go ahead and be built. And then once we've set our printer in the top left-hand corner, what we can go ahead and do is just preview this design. So once we preview this design, this is then going to go ahead and create us 3D printing toolpaths. So it gives us the ability to go ahead and see how that design is actually going to be built and the overall estimated time to build that design and the estimated volume of it. So it gives us the ability to quickly and easily start to set all of that 3D printing information directly just here. Now, we also may want to go ahead and additively manufacture that mold core. So we're going to go ahead and create a mold for that, for the housing of this reciprocating saw. So we want to go ahead and create that core. So popping into our CAM environment, what we can go ahead and do just here is we have the ability to quickly and easily start to see those changes that have been made, so we can update if we need to. But we can start to set up this design and create the kind of design that we need. So the first thing I want to go ahead and do is just create a setup. Now we're not going to go ahead and cut the whole thing because that's our table just there and those are our fixtures. So what we can go ahead and do is zero in on the area that we want to go ahead and work with. We can add in any stock that we need to, and we can also go ahead and start to look at setting our Z and X planes and exactly where those coordinates are going to be within our design itself or within the setup itself. From there we can then start to add in the toolpaths. So whether these are 2D where we'd have to go ahead and select some contours, or whether these are 3D which are a lot more algorithmic based but a lot more adaptive. We can quickly and easily start to generate the type of tool that we need or the type of tooling path that we need. So we have a whole host of different tools within our library as standard, but we can also add in our own, and really quickly and easily we can then go ahead and start to specify maybe some rest machining if we need to. We can specify the bottom height of the design, so if I wanted that to be there, so that's the bottom height of the tool, sorry, and any stock to leave at that stage. And if we click OK, this is then going to go ahead and start to set up all of those 3D machining toolpaths for us. So it gives us the ability to quickly and easily start to see how that design is going to be cut out of a bit of billet or a bit of stock material. So really quickly and easily we can then go ahead and not just take that design from just, like I said, a standard design that we create within software. We can actually go ahead and start to manufacture that directly within Fusion. And it's just a simple workspace switch, making it very quick, very simple to go ahead and do that. So once the adaptive clearing is done, it's just doing a very quick roughing strategy to get rid of a whole host of different material. We may want to go ahead and finish off this design by just making some small or putting another strategy in place. So that's our adaptive done. We may also want to go ahead and use a parallel just to go ahead and create a finishing strategy for the design. So again, picking up on the tool that I want to go ahead and use. We can also go ahead and choose the boundary that we want to go ahead and machine as well. So if I pick up on that one just there, and maybe that section just there, that's the only area that we want to go ahead and finish machine. And again, if I click OK at that stage, this is then going to go back and start to create that parallel strategy for us as well. Again, creating all those parallel toolpaths. Now, prior to going ahead and creating or cutting any material, what we can go ahead and do at this stage is start to look at how or the simulation of that machine. So if I go ahead and just hit the toolpath to tail, we can start to see how that part's actually going to be cut out of that billet material. So it makes it very quick and easy to go ahead and see if there are going to be any clashes or any design changes that we need to make directly to that mold, giving us the ability to quickly and easily start to develop those toolpaths virtually in Fusion prior to going ahead and posting out. When we're ready to, we can hit the post process, and this is then going to go ahead and start to generate all of the NC code required to go ahead and cut that design. So if I wanted it to be just a generic FANUC, we can go ahead and specify a generic FANUC, put that post in, and this is then going to go ahead and give us all of that NC code with all the tooling that we're using to then go ahead and generate that product from a bit of bill of material, making it very quick and easy to go ahead and take a design from not just a art or a concept level design all the way through into more of a part level design by actually creating the part itself. So very quickly and easy we can go ahead and make all of those designs exactly as they need to be. So what we've looked at today, we've gone through the design aspects, so having the ability to go ahead and do T-spline modeling, so some very free-form shapes, moving that into parametrics, having the ability to quickly and easily start to cut material using standard lines art sketches, having the ability to offset parts very quickly within Fusion, then also create all of those mechanical links. Moving that design across into some make environment, having the ability to go ahead and add in CNC toolpaths, but also going ahead and looking at the additive side of things as well, and the additive manufacture. And then the final use side of the product portfolio is actually putting that product out to use and having some tools that we can then go ahead and use to gather data and then start to inform that design process a little bit sooner. So one of the key things with Fusion 360 is that we're completely open with its development. So what you can go ahead and do is go to that web address that you can see just there, autodesk.com/products/Fusion 360 and the blog. And we actually publish our development roadmap for Fusion 360 live. So you can then go ahead and start to see all the elements that we're working on to develop Fusion 360 for the future. So for this roadmap, you can start to see what we're working on for sheet metal, ECAD electromechanical, simulation, CAM. So it gives you the ability to quickly and easily start to see what the future of Fusion is going to look like. One of the other key things here is we want Fusion to be built by our user base. So from here, what we want to go ahead and do is have you guys inform us what kind of features you need for Fusion. And you can do that via Idea Station. Again, from the blog, you'll see a link. And from there, you can quickly and easily start to inform us as to some of the ideas that you can then go ahead and work with, or some of the ideas that you need or features that you need for Fusion itself. So very quickly adding that directly into Fusion itself. So if you want to find out more about Fusion 360, you can, like I said, you can visit us at autodesk.com/fusion or any of the social media handles that I mentioned earlier on in the presentation itself. Thank you guys for joining this webinar today. It will be available on YouTube later on, so by all means you can review it just there. But again, thank you guys for attending. Thank you guys for your attention. Have a great day. Thank you guys. Bye-bye.